Hello friends. So I hope you have already reached the previous video where we found out the majority element using brute force approach. Cool. Now in this array we will do like same question but which is taking better time than the previous time complexity, which is previously took order of n square, right? Now let's see the better approach, which is taking less than n square. Okay. So that approach is simple sorting approach. So I'll be taking same input array. Now see here. So this is the given input array, right? Now what I will do is I'll simply sort this given input array. Now I'll tell you like why I am sorting. So it's a very beautiful idea. So if I try to sort it, what will happen? So I think first 2 will be coming here, 2 will be coming. Then I think 2. Okay, so then 3 comma 3. Okay, after that I think remaining all are 4s. So total 5 4s are there. Okay. Total 5 4. So I just sorted this input array. So this is the input array, and on top of input array I have applied the sorting, so which is in the increasing order. Okay, I applied the simple sorting, right? Once you sorted this array, now the idea comes. So see, we already know that what is meant by the like majority element. If there are n elements are present, if I am saying any element as a majority element, so maybe I'll be taking, so let's say 6 elements. I'll be taking, let's say 6 elements. 1. So let's say 1, 2, 3, 4, 5, 6. 6 elements I have taken. So 0, 1, 2, 3, 4, 5. So initially assume no elements are present, 6 elements. Okay. Now I have sorted this array, friends. Okay. After sorting, so let's say here some elements are present. Okay. Now don't worry about the what elements are null. So do not worry about. So some elements are present here. Assume all elements are same. All elements are same. Let's say you are sorted. Okay. All elements are same. Then after this, if you found that next element is same, then I can say 100% sure that yes, that element is my majority. Why? Because it should occupy half of the space of the array. Yes, because it should present n by 2, minimum n by 2 plus 1. So half of the array if that element is occupied. After that, if at least one cell if that element is present, then 100% I can say that element is majority. Okay. Now here I have sorted my array. So 9 by 2 is how much? So 9 by 2 is nothing but 4. Okay. Now try to compare. So let's say after sorting, you start the story from the first element. Okay. Let's say all elements are sorted, friends. Okay. Now I'm giving just an idea. Okay. So I will be pointing at 0. Assume you have sorted this array and let's say 2 is my majority. Just I'm saying, assume though here 4 is my majority, but for the time being, let's assume 2 is the majority and you have sorted this array. Since I am saying 2 is majority means definitely 2 should present minimum 5 times. So therefore, let's say here also 2 is present. Here also, actually the 2 is not present because it is not a majority, but let's say just assume that. Okay, if really this 2 would have been a majority and I sorted that array, then definitely this 2 will be present minimum 5 times. Which means I can say the element that is present at index number 0 and the element that is present at the 4th location will be exactly same because I have sorted. That 2 is a majority. But now let's compare. Does really, okay, sorry. Now let's try to compare. So 2, 2, so this will be 3, 3, 4. So this will be 2, 2, 3, 3, 4. Okay, so just a minute. So I have sorted this array and this is the output that I have got, friends. Now clearly, now element that is present at index number like this element and the element that is presented here are not equal. So therefore, this is not a majority. Now I will go and see it in the future. Okay, now here again, if this has to be majority, if I found a majority means I will stop it. In fact, after that I don't even go also. Okay, now let's say if you found a majority and you did not stop it here, after that if you go now, what will happen? The real value you are trying to miss out. Okay, if your I is pointing at index number 1 and if this has to be majority, from here the next 4 elements should occupy this element only, then only I can say that is the majority, because you are sorted that input array. Now again see, so when I is at 1, okay, and now this I is at, let's say, equal to 5, for example. See, similarly at a time both cannot be happen. If I is at 0, and try to check what is the element that is present at the 4th location, okay, you see if they are equal, then I am happy, that element is my majority. Same story, if I is at 1 and you check the array of I, so simply what does I mean to say here, array of I versus array of I plus. So tell me what I need to write here, what I need to write. You can think for some time and tell me. Okay, so this we will fill it in some time. So if you are having a doubt, we will fill. So as I said, now element that is present at 0th index and 4th index not equal. Again, the element that is present at 1st index is not equal to element that is present at 5th index. Now which means, so array of 0 and array of 4. Same as array of 1 and array of 5. Okay, now I'll increment I. So I'll remove everything. Now I value will be now pointing at here. Again, if this has to be majority, so from here, let's say here also it should be 3, here also it should be 3, here also it should be 3. After that, if 3 also, no problem, but minimum 5 times it should be there. That's it. But it is not present. So therefore, element that is present at 2nd location is not equal to element that is present at the 6th location. So not equal. Again, element that is present at here. So if this 3 would have been present, then we have to stop the story only. Otherwise, next time if you go now, from here, next to 4 elements, if the 3 is not present, then there will be a problem. Because earlier you found that 3 is a majority. Once you found a majority, if you did not stop now, then there will be a problem. So please take care. Now here also it is not a majority. Now let's go and check for this element. Okay, now exactly I have reached half of the array, friends, which is 9/2. You reached here. Now again compare. So element 3, which is 7. Next that is 4 and that is 8. Now luckily here they are equal. So luckily they are equal. Array of 4 and array of 8, which means 4 is a majority, and you can stop the process. You have to stop the process. See, these all things are working based on you have sorted the array. Otherwise, this would have been won't work. Okay, right. Now tell me, friends. Let's say instead of 4, if 3 is present here, and you have reached half of the array. Okay, you reached half of the array. Actually, here only half. One more time you went. Though you, let's say you did not found that majority, then tell me, is it required to go second half? So this is nothing but first half. This is nothing but a second half. In the first half, if you did not find a majority, then is it required to go and search it in the second half? Not at all required. Why it is not required? Because if it has to be a majority, means half of the place it should supposed to occupy. After that, at least once it should supposed to present. In the first half itself, if that element is not present, then what you will go do and in the second half? Tell me. So not required. Just in the first half, you see, if you didn't found majority, then that is enough. That is enough. So very good intuition this is. So it's working simple based on the sorting that array. Now you see 0 after adding how much I am getting 4. So 0 plus 4. For this one, how much I am adding, I am getting this value plus 4. To this 2, how much I am adding? Plus 4. So every time to this I value, I am exactly adding plus 4, plus 4, plus 4. What does that plus 4 with compared to n? That is n/2. So which means array of I plus array of I plus n/2 should equal. Right? So now let's see how we can code this. So maybe I'll code it here only. So let's say. Okay, so I'll code it here. So first you need to sort the array. So you can use the collection as arrays.sort. You can pass the input array. So this array will be sorted. Now you can run a simple for loop. So I is equal to 0, which can go till half. That is enough. Okay. I plus plus. Now you compare array of I is equal to array of I plus n/2. If this is equal, you can stop the story. Okay, so return array of I as the majority. Otherwise, loop will be getting incremented. At the end, if it is not returning anything, means no majority. So you can write simply return -1. Okay, cool. Now let's say at 2 base cases, this program might fail, friends. Let's say if they are passing only 1 element or 2 elements in the input array. If they are passing only 1 element, if they are passing only one element, then always I can say that element has a majority. Okay, then always I can say that element has a majority because it should present more than half of the time. Half is nothing but 0.5 plus 1, right? So when you have one element, I can say 1. Okay, let's say if somebody is contesting in an election, if only one person is standing, so you can declare that that person is a winner. No need to conduct that elections also. Let's say total 3 parties are participating in an election. Okay, party 1, party 2, party 3. So out of these 2 parties, no member came for the contesting. Only one fellow came. So we can directly declare, okay, anonymously you can declare this fellow as a winner because other 2 fellows are not even participating. So here we are having only one element. That element itself we can say it is a majority. Okay. So these cases you can handle. So if n is equal to 1, okay, so you can return that element itself is the majority. Now if you have 2 elements, let's say if you have 2 elements, then there is a problem. If 2 elements are same, then I can say yes, a majority. But if they are not equal, then that is not a majority. Okay, so you can even check that also. If n is equal to 2, you can check. Okay, I'm writing in a single line in a ternary operator. If they both would have been equal, array of 0 is equal to array of 1, which means both elements have the same value, then obviously that is a majority. If this condition is true, you can return either 0. If this condition would have been true, then you can simply return array of 0. Since they both are equal, you can either write array of 0 or you can write array of 1, no problem. Otherwise, minus. If minimum 3, then you can continue the remaining code. Okay, so if let's say if minimum 3 elements are there, then the story will start from here. Otherwise, story will be ended here itself. Okay, so good intuition this is, right? Now let's analyze the time complexity, because from one approach if you are going to another approach, there should be some impact on the time complexities, correct? See, now again input array n is the size of the array, so these you can anyhow ignore because these are the base cases. This is important, friends. Okay, so this sorting will be taking n log n time. So how it is taking, like when I explained about merge sort and quick sort, so there I will talk in detail how arrays.sort is getting time complexity n log n. For time being, let us assume that the sorting is taking n log n time. Okay, how I will talk it in the when I talked about like sorting algorithms. Okay, now see how many times this loop is running. Roughly half of the times this loop is running. Because starting from 0 going till n by 2. So half of the times this loop is running. So when they are like one after other, you have to add it, but one inside another you need to multiply because it is not a nested, right? So n log n is separate plus n by 2 is separate. Now compare n log n and n by 2, which is better? So asymptotically this half you can cancel, so which means you can write this as n, no problem. N into something you are multiplying, and this is n only. Obviously n log n will be bigger, so because log is a positive increasing function, right? So n you are multiplying something, so definitely this is bigger. Therefore the time complexity will be, the time complexity of this algorithm is order of n log n. Order of n log n. What about space complexity? Space complexity will be order of 1. Okay, so here sorting algorithm, recursive stack space we are not considering, so that's why space will be order of 1. Why space is order of 1? Because here apart from given input I am not taking any extra or anything, only variables I am taking. So for the variables it will be order of 1 always. Okay, cool. Because let's say when I explained about quicksort and merge sort, so there actually they are nothing but recursive algorithms, friends. So there you need to even consider recursive stack space also, but let's for time being let's not worry about what that recursive stack, what all those things. So just to assume that the time is like just know that time is n log n and space is order of 1. Now if you remember previous approach where we have taken time as order of n square. Now compare it to order of n square, n log n is better. N log n is better. So n square, n log n, something better. Cool. But is there any better approach than n log n? So can you do that? Yes, we have some other approaches, friends, like better than n log n. So now you can think for that. In the next video, I'm going to discuss about that better approach. Okay, cool. So thank you for watching. We'll meet in the next video.